Hi everyone, um, my name is Abel Gray Katoma. Okay, on this video I'm going to focus on beam design. Okay, I'm going to be using your RCC spreadsheet, which if you have been following is actually much more easier than your RCD 2000. Okay, it's much easier and much faster, okay, than your RCD 2000. Now on RCC spreadsheet, you find out that your BF is automatically generated. Okay, uh, they are all automatically generated. It gives you your BF and all that. Okay, if you are enjoying what you're seeing, why not give it a thumbs up? Okay, subscribe to this YouTube channel. It's actually free, you're not going to pay a dime. Okay, you see a red button down below. Click on that subscribe button. Okay, click on the bell icon, okay, so as for you to be notified whenever I post a video. I usually post videos on a weekly basis, sometimes on a daily, okay, so as to encourage people who are trying to understand how to design. Okay, without wasting much of our time, I'm going to maintain the same GA that we have been using right from time. This is our beam 1. Okay, if you have been following on RCD 2000, okay, this is our beam 1. Now we have how many spans? 1 2 3, which is this 1 2 3. So here we type 3. You can see there's 3 there already. It's now asking you what is the maximum span. Okay, you are going to just pick the value of the maximum span. Now it happens here that this whole beam actually has the same span. Okay, it is 3830. So we're going to write 3830 3.83. okay, the depth of the beam, okay, 450. The breadth of web, 230. Okay, that's the width of the beam. Okay, your height of flange, okay, is actually 150. That's the thickness of the slab. Okay, then your breadth of flange, you can see that it will just generate your BF automatically. If you have been following before, you know, like I told you, since this beam is actually an L beam, for example, if this beam is a T beam, what do we do here? You change, instead of L you change it to T. Okay, you change to T. Now it gives you 498. If you can remember from our last class, told you, I explained how you can get your BF manually. You can see from this little formula, once you use this you get this manually. Okay, so there is no scam in this. Okay, you will be able to confirm everything that is actually correct. Okay, what is the self weight? Your self weight, okay, you can remember from the instructions we read from the beginning. It says enter data in blue cells only. Okay, 3 or more spans with uniformly distributed load. Okay, red messages indicate entry errors. Single layer rebar only. Shortest span must be. Now because our maximum span is 3.83, it's telling us here that in this beam the shortest span must be greater than 3.256. Now if it is less than, I don't want to go deep into explaining these. Okay, but down below the description of this video, in our description box, our YouTube channel is actually there. You can see our videos, you can follow us. I've done videos on RCD 2000, I've done videos on Protac Structure, Orion, and AutoCAD. Okay, you can follow, you can leave a comment, okay, and then I'll do well to answer your questions. Okay, here our self weight, you can see it says enter data in blue cells only. Okay, so you don't touch that. Okay, our dead load. Now coming to dead load, if you can remember, on our slab design that we've done already before, now the load you put here or you impute here is actually your equivalent load on beam. Now since in RCD it does this calculation for you itself, okay, but on RCC spreadsheet you have to get that value manually. Now I'm going to show you how to briefly do that. Okay, it's actually very simple. There are simple formulas. Okay, so don't be afraid, don't be scared. I know that you're already scared. Okay, for long span is 1 over 2 your W LX, okay, open bracket 1 minus open bracket 1, okay, subtracted from 1 over 3 K square. Okay, now your K square is your K is actually L over X. Okay, I believe you know what your L is. Your ly is actually the long span, your LX is actually the short span. So when you divide your short span divided by your long span, you get your K, the value of K. Okay, now to calculate for short span, the equivalent load on beam for your short span is 1 over 3 WLX. Okay, your LX is the short span, okay, of your slab, the shortest span, the short span of your slab. Okay, your one way is 1 over 2 WLX. Okay, we are going to come back to that. Now since we are designing our beam, okay, which we have 3 spans. Okay, we have 3 spans. Now the longest span, what is the load that is actually acting on that on the longest span? Now from our RCD 2000, if you can remember, on our long span we're able to get 17.608, which are approximate to 61. Okay, 17.61. Now if that is correct, now I'm going to show you briefly how to get this here. Now your long span for your equivalent load on beam for panel 1, okay, your long span 1 over 2 WLX. Okay, your W, if you can remember, which is this, which is your load, your design load, which is 10.52 kilonewton per meter square, okay, of your slab. Okay, of your slab, where are we? Okay, of your slab multiplied by 3.83, which is the short span. Okay, 1, okay, minus, this is 1 over 3 into brackets your LX over LY. Okay, when you divide your LX, which is 3830, divided by 6230, this, okay, 3830 divided by 6230, which will actually give you 0.615. Now you square it. Okay, if you do this little calculation, you'll be able to get 17.608, which is the value they actually got from your slab design in RCD 2000. If you can remember, if you have been following us on your long span, you confirm that this is 17.08. Now on RCD 2000, it generates this, it does this calculation for you itself. Okay, but on RCC spreadsheet you have to do it manually. So, and that is the formula you can use in getting this value, which we got 17.608. Now in your short span, which is 1 over 3 multiply by 10.52 times 3.83. Yes. So 1 over 3 your design load multiply by this. Okay, and this is how we got 13.43. if you come back to your design for your short span, 13.43. okay, so that is that. Now look at this beam now. Okay, the spans are actually equal, right? So let's assume that these spans are not equal. You pick the maximum span. Okay, and in most cases the maximum span, the longest span of your beam, will most likely have the highest load. Okay, most likely have the highest load. Now we definitely have the highest load, so you pick the long span, specify the load, you type in the load, which is 17.6, which we got there. Okay, 17.6.61. okay, your total dead load. Now this will sum this for you and give you this. You can see this is black. You are not supposed to edit this. Okay, your impulse load 1.5, then your design. Now it designs this, which is 29.4. okay, your FCU 20, FY 410. okay, for your mile steel 250. okay, once you impute those values, you come down here, you check. Now you can see your bar cover, okay, single layer, okay, bar spacing, okay, deflection is okay, shear links is okay, everything is actually okay. Now if it's not okay, it will tell you. Okay, you can see, to have better, to see more details of your design. Okay, this is the weight, this is the graph. Okay, and that is that. We are done with our beam 1. okay, we are done with our beam 1. Now let me design that of beam 2. Okay, now to design your beam 2, number of span, which is this is our beam 2, right? Our beam 2, we have just one span, is simply supported. Okay, we just have one beam. Maximum span is 3.83. if you can remember, look at it, it's 3.83, this beam. Okay, okay, the depth, the BW. Now look at, it is showing you that your BF is not supposed to be 544. That means there is a problem somewhere. Okay, it has already designed it. Now remember that this your beam is actually a T beam. Okay, your beam 2 is a T beam, so that's why it's showing you red here. Okay, that 544 is not the BF. okay, the breadth of flange is not 544, so we have to change it. Although it has designed it already, we don't need to do this calculation manually, just like the way we did in RCD 2000. No. Okay, your HF is 150. Here now it has designed it. Look at BF 498. So we'll change this to 498. Okay, click. You see it's no longer showing you red. Okay, your top cover, your bottom cover, your side cover. Okay, the characteristic strength of concrete, you can make it 20. Okay, like that, and that is all. We are done with our beam 2. Okay, we are done with our beam 2. But now this dead load, you know, like I told you, you pick the value from these, your equivalent. Like I told you, you always design your equivalent load on your beam. Okay, your equivalent load on your beam. Equivalent load on your beam. What is the slab that is actually acting on this beam? It is panel 4. Panel 4 is actually acting on this. Okay, now if you go to your calculation, okay, like the one we did in RCD 2000. Okay, your panel 4, you see you have 9.10. Now let's do this calculation manually because we are using RCC spreadsheet. Okay, so in RCC spreadsheet, to design this, now what you do is to design this, the formula is 1/2 WLX. Okay, which is 1/2 multiplied by 10.52 multiplied by what is the span of that slab, 1730. So what will now be our value here? 1730. So here 1.73. so if we say 0.5 times 10.52 times 1.73, so if we do this right, this is what you get, 0.1. okay, or let's say 1.1, 9.1. okay, now this is what you have. So you come back to your RCD, you'll come back to your RCC, sorry, type 9.1, and that is it. Now you see that this value down here will change. You see it has changed. Look at your bending moment diagram. Okay, you can see how it bends. This is your bending moment diagram. You go down, you see everything is okay. Your deflection, everything is okay, and that is that. If you enjoy what you are seeing, why not give it a thumbs up? Subscribe to this channel. It's actually free. Down below you see a red button, subscribe. Just click on that subscribe button. Okay, and a bell icon, click on the bell icon so as to notify you whenever I post a video, which I post on weekly basis, sometimes on a daily, so as to encourage people who are trying to get a better understanding of design. Okay, I can come in your design. You have a design and you want me to come in. Okay, I can do your designs, your electrical, mechanical drawings, your service drawings, yes, your structural, both design and detailing. Okay, bar bending schedule, your concrete volume. Okay, your architectural working drawing, both 2D, 3D drawing, interior design, landscaping. You can contact me down below the description of this video. You have my WhatsApp contact, my YouTube channel. Okay, and then we'll schedule a date to talk.